We're going to answer this question before us. It says, in a random experiment, the probability of A is equal to 0.6, the probability of B is equal to 0.54, and the probability of A intersection of B complement is equal to 0.4. Find the probability of A given B. Let's begin by just writing down what our conditional probability formula tells me. The probability of A given B is going to be equal to the probability of A intersection of B over the probability of B. Now, the issue that we're facing now is I don't know what the probability of A intersection of B is. I know the probability of B is 0.54, but I don't know this. Now, there are a couple of different ways you could find it, some quicker than others. I think the longest way to possibly do it is to make a Karnoff map. And even though it does take a long time, it is a reliable way to do it. And I think that people would be less likely to make a mistake if they did make a Karnoff map to figure this out. So let's just quickly draw ourselves a Karnoff map here and fill in what we've been told. I know that 0.6 is my probability of A. Whoop, that's not A. It'll be down here. And I know that probability of B is 0.54. So B is 0.54. If I know that the probability of A intersection of the complement of B is 0.4, A, B, it will be here, 0.4, which means I can figure out that the intersection of A and B is 0.2. Now, I think that took a long time. I'm not quite sure if that's it's definitely not the efficient way to do it. I think a better way to perhaps do it is to picture in your head a Venn diagram. You've got A, you've got B, and you've been told that A intersection of the complement of B is 0.4. You know that this is just referring to the A section here, 0.4. So therefore, where these intersect, this is going to be 0.2 because you know that they has to add up to 0.6. So that's probably a quicker way to go about it. But either way, as long as you get the answer, it doesn't really matter. Okay, so now let's answer this thing. The probability of A intersection of B, we said was 0.2. The probability of B was given, it's 0.54. So what's 0.2 divided by 0.54? If we simplify that down using our calculator, it's going to be 10 on 27.